Hey guys, Mr. Thibodeau here. So I wanted to go over lesson 4 here. The important things to know for lesson 4. So first you're going to start off with your mental math. And the goal here is to do the mental math in your head. You don't need to write them out. Maybe that was a little confusing last time. So just try to think about it and do, like, say 5 score, 5 times 12. Just do that in your head. Just put the answers down in here in your math book. Okay. New concepts. Problem solving is good. I think these are interesting little asides. I think they're a good little warm up. So I do want you to try those as well. Next thing to go over is new concepts. Okay. So here we're talking about number lines, and really this isn't a new concept per se. But the way it's going over all of this chapter is really designed to try to help you build a certain schema in your head. And what that means is they want you to try to change how you think about math. Everyone kind of understands math in their head a little differently. And some ways are generally more successful than others, but that doesn't mean any way is right or wrong. Anyway, they're trying to get you to think about how we add and subtract things, and they're thinking about it within a number line. So let's go ahead. Let's start with some definitions. So let's move this up a little bit. All right. Lesson 4. So number line is essentially an infinite line. Right? All lines are infinite. That you have numbers on, really. I mean, I don't know if you get more complicated than that. Numbers, or I'll say points on it. Okay. Now, the 0 point is called the origin. This is where we start, okay? And anytime we're talking about it from here, the origin, that is our baseline. Okay, let me actually move this so you can see everything. So we have always, always, always to the right of the origin is positive, and always to the left is negative. In English, in any case, there are other countries that do some stuff a little differently, but generally we always do, and math is usually pretty universal in this. The left is the negative, to the right is the positives. Okay. And that's the left of the origin. Okay. These are greater than 0, and over here less than 0. Right? The greater than, less than symbols always open up to the bigger number. So whatever is on this side of 0 is bigger than 0. Whatever is, there we go. Whatever's to this side is less than 0. I said one thing and then my brain did another. All right. I think that's all you need from that. On the number line, the tick marks indicate location of integers. Okay. And what that means, integers are any counting numbers as well as their opposites. Any numbers, any like whole numbers, really. There you go. So 1, 2, 3, -2, -3, -4. All of those are integers. So let's go ahead and let's put integers down. It's one you've definitely seen before, but we'll write it again. Whole numbers, negative numbers, and 0. Anything that's not a decimal is an integer. Okay. It says positive integers are infinite, and negative integers are also infinite. They go on forever. There is not a number. There's no last number. It always can go bigger. Okay. You can always add another 0 or another number to it. Ellipses represent dot 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 are the same as the arrow. That means that it continues on that way. Okay. We can compare two numbers using less than, equals to, or greater than. Okay. So -5 is less than 4. So -5 is less than 4. 3 plus 2 equals 5. When you think of the equal sign, think of it as a scale. Okay, whatever is on this side is perfectly balanced to this thing. Okay, Thanos with his little knife, perfectly balanced, like all things should be. Okay, -3 plus 2 is in the exact same balance as 5, and we know that because of that equal sign. Okay, 3 plus 2 equals 5. And then we have 5 is greater than -6. Okay. When we do these greater than, less than symbols, we always start with the leftmost number when we talk about it. So technically, -5 and this symbol and 4, this also means that 4 is greater than -5. But we wouldn't say that because 4 is to the right. So instead what we would say is -5 is less than 4. Over here, 5 is greater than -6 because 5 is to the left. So that's what we're comparing -6 to. Okay. Arrange these numbers from least to greatest. Over here, it's just kind of a different way of thinking about adding and subtracting and using the number lines. Same sort of deal. I can't remember. I think I did this in a different thing. I want you guys, you may or may not already have a little bit of practice with this. When we're talking about negative numbers, right, 376 minus 840, you will not get the correct number if you try to do 376 and 840. If you try and subtract this traditionally, and you got 6 minus 0 is 6, 7 minus 4 is 3, 3 minus 8 would be -5. Okay? If you did -536, this is an incorrect answer. Okay? The correct answer, as you see here, is 464. So you really have to flip the numbers so that the bigger number is on top and the smaller number is on the bottom. And then you have to add the negative symbol. Okay, the correct answer is negative 464. Okay, so when we actually do this, it's 840 minus 376, which was what, 464? But it's negative. And we know it's negative because just looking at 376 and 840, I know that 840 is bigger than 376. So I know ahead of time that I will have to have a negative number. Okay. Sequence, just kind of arithmetic patterns, basically. Geometric sequence. 1, 2, 4, 8, 16. This is actually my favorite. This is Fibonacci sequence. Oh, you can't see it. I don't know why it's suddenly not doing auto zoom or autofocus. Let's see if that helps it. You try and figure out if something is an arithmetic or geometric sequence. If it is an arithmetic sequence, you will know that the difference between them is regular, okay? Where it is adding a certain amount each time, or is adding a consistent amount. So does it add 2 each time? Okay. Does it increase by an odd number each time? Okay, so increasing by an odd number each time is how that's going. But this isn't oh, that's interesting. These are also perfect squares. I didn't realize that. Yeah. Think this, I don't want to get too distracted because I feel like if I try and explain this, I'm going to go off in a different tangent than what the book wants you to do, and I don't want to confuse you too much. I think the book will does a good job of setting this up. So I wanted to give a little bit of information for lesson 4, but I think the rest of it is stuff you guys can do. For your actual work, for the written practice here, I'll write down. So you'll do the practice set on your own. But then for the written practice, I want you guys to do, I think just 1 through 17. I think that'll be fine. 1 through 17 all, and I think that's all I want you to do for this. Yeah. Okay. That is what you're doing for lesson 4. Have a good one.